Who's ready to add and subtract rational expressions and also something called complex fractions? So I know you guys had a blast multiplying and dividing fractions, but now I know you're super pumped up to add and subtract rational expressions. Okay, which actually, you guys, adding and subtracting rational expressions is very similar to just adding and subtracting two fractions. So let's talk about how to do this with just normal fractions. So adding and subtracting fractions that already contain a common denominator. So if you see here, both of these scenarios, the denominators are the same. And this one, both of the denominators are a 5, and both of the denominators over here are a 7. Okay, so when you add and subtract fractions, you must always have a common denominator. You cannot even try to add them if the denominators aren't the same. So if the denominators are already the same, it makes your life infinitely easier because you already have a common denominator. So in these, you guys, since the common denominators are the same, what we're going to do, you write the fraction over one denominator, and it's going to be the common denominator, which in this case, in the first one, that would be over 5. Okay, so both of these have a denominator of 5, so the common denominator will be 5. And all you got to do is add the numerators together. So 1 plus 3 will give us a 4. So 1/5 plus 3/5 is 4/5. And if you can, you guys, it's always good to simplify if you can, which I can't divide anything into 4 and 5. So this bad boy right here is simplified. Same thing when you subtract with two fractions with common denominators. So once you get a common denominator, you write it over one of the common denominators. So in this case, we're going to write it over 7. And then you simply just subtract the numerators. So 6 minus 4 will reduce down to 2. So it's 2 over 7. Be careful, you guys. Common mistakes, people try to add the denominators together, but that is the demon cats talking to you. Do not listen to them. Don't. Okay, so ignore that. You just need to get a common denominator and write that thing one time. Okay, so we're going to be applying these same concepts when we have polynomials. So get excited. Okay, so if you see here, these polynomials have the same common denominator. The common denominator in the first example is x plus 3, and the common denominator in example 2 is x squared plus 2. Okay, so here are the steps we use when we add and subtract fractions with common denominators. First, what we're going to do, be careful. All we're going to do at first is factor the denominators only. I know that when we multiplied with fractions and divided with fractions, okay, we factored everything. Not anymore, and it'll make more sense when I do the example problem, but take my word for it, you guys. When you're adding and subtracting two fractions, you only factor the denominator. Leave the numerators alone. It's not wrong to factor the numerator, but you're going to end up wasting a lot of time and doing a lot of work that you don't need to do. And don't forget, you guys, you need to make sure the term with the highest exponent is positive. And remember, if it's not, what do you have to do with it? Holy hot dog, you guys are so smart. You do factor out a negative to make it positive. The next step will determine where the expression is undefined. Remember, we can never, ever, ever divide by 0. Never. We are not in the kitten killing business. When you divide by 0, a kitten dies. So remember, we have to set each factor in the common denominator not equal to 0. Okay, which these will already have common denominators, so you don't have to worry about that common denominator part. Then we're going to come up with a common denominator, but again, these already have one, so you won't have to do that yet. In a little bit you will, so wait for it. Okay, you'll make the fractions have a common denominator if they don't have one, but guess what these do? Okay, after you have a common denominator, so really, you guys, we can skip steps 3 and 4 because they already have a common denominator. And then step 5, we're going to add the numerators together and keep the denominator as the common denominator, just like we did over here. Keep the common denominator and add or subtract the numerators. Okay, after that, remember though, be careful. When you subtract in front of a fraction, there's secretly a -1 in front of the fraction. So we're going to end up distributing that secret ninja that is -1. But we'll address that in the example video. And finally, we will simplify and factor the numerator if we can. And after we simplify and factor the numerator, if we have any like like factors in the numerator and denominator, we'll cancel those bad boys out like we did when we multiplied and divide. But anyways, go ahead and pause the video and watch example problems 1 and 2. That's the funsy, so wait for it. Alright, so the next phase, our next fractions are not going to have common denominators. So we need to know how to make a common denominator, which we're going to start with just simple, plain old numbers, because it's actually the same process when we have a polynomial, right? Okay, so when we make a common denominator, the first thing we're trying to do is we're trying to come up with the smallest number that both denominators can multiply to equal. So we want, this is usually called the least common multiple, but I'm just going to call it the common denominator for now. So we want the smallest thing that 2 and 3 will multiply to equal. Holy hot dog, you guys are so smart. That's 6. And CD is common denominator. So this one would have a common denominator of 6 because the smallest thing that 2 and 3 multiply to equal, that is the same number, is 6. Okay, so let's talk about this. 6, if I break down 6 into its factors, the things that go into 6 are 2 and 3. 2 times 3 is 6. Wait a minute. Do you guys see a connection between this 2 and 3 and that 2 and 3? Oh man, it is not a coincidence, you guys. One of the techniques we use for making common denominators, what we're going to do is we're going to select one of each factor. Okay, so what I did here was I selected one of each factor, okay, and then we multiplied them together and got 6. So what we're going to do, eventually, when we can, we are going to factor the denominators, okay, and then we're going to grab one of every single factor we see. So we're going to grab one of every different kind of polynomial or number that's in the denominator after we factor. And once we grab one of each of them, we multiply them together, and bam, you got your common denominator. All right, now this one is slightly different. You're probably like, no, it's not, Miss Long. It's just making a common denominator. Well, I'm going to point out something that comes up when we solve with polynomials. Okay, so anyways, over here we pulled the 2 and the 3. So sorry, I forgot to mention that. So we grabbed one of each of these, the 2 and the 3, to give us 6. But anyways, let's go back to this problem. Okay, first of all, when we find a common denominator, the first thing you must do is to factor the denominators. Okay, which 4 has factors. It breaks down into 2 and 2. The reason why we didn't do it over here, you guys, 2 and 3 don't really break down into anything except 2 in itself. Okay, we want to break it down into its prime factors. So things that only 1 in itself will go into. Okay, which 2 and 3 were already good to go. Okay, so 4 will break down into 2 and 2, which 2 simplifies to be 2 squared. Okay, so 4 factors down to 2 squared. Okay, now let's think of the things that go into 6. So 2 things that go into 6, you guys are too cool for school. That is 2 and 3. Okay, so the first thing, we need to factor the denominators. Then like over here, we need to grab one of every different kind of number we see, which I'm seeing 2's in each denominator and I'm seeing 3. So I'm going to be grabbing some 2's and 3's eventually. So let's see what happens. Okay, so anyways, we also need to think about what's the smallest thing that 4 and 6 go into. So the smallest number that 4 and 6 both multiply to equal, oh man, you guys are so smart. It is 12. Okay, so our common denominator in this one is 12. Okay, and 12, if we break it down into its prime factors, okay, 12 breaks down into 4 and 3, but 4 can break down into 2 squared like you see here. So this is kind of like 2 squared times 3. 2 squared is 4, and 4 times 3 is 12. So let's see, how do we get this answer from what our factors are? So if you see, I grabbed one of every single different number. I grabbed the 2's and I grabbed a 3. Now you're probably like, holy hot dog, Miss Long, what are you talking about? How do you know which 2 to grab? Because in this fraction we had 1 2, and in this one we had 2 2's. So how do you know how many of each alike factor we grab? Well, there's a way to get around this. Okay, what you're going to do, you're going to select one of each factor. If the factor repeats, So the factor of 2 repeated in this first fraction and the second fraction. If that happens, you must select the factor with the highest exponent. So 2 was the common factor, and the one that had the higher exponent was the one with the 2 squared. Okay, so if you ever run into that, if you see any of your factors are repeating between both denominators, you must pick the one with the highest exponent. Okay, and this CD, you guys, is common denominator. Okay, well, these same principles are going to be applied when we have polynomials. So these steps for coming up with the denominator, we're going to imagine that these are denominators of polynomials. So they're not in the numerator of the fraction, they're in the denominator. And the goal is to make a common denominator between these two fractions and these two fractions. So what we're going to do, first of all, we have to factor. Okay, which these are already factored for us, but after that, if any factor repeats in one of the denominators, you write the factor once and raise it to the exponent. Okay, so if you ever see something repeat like x minus 1 and x minus 1 underneath one fraction, okay, you just write x minus 1 once and raise it to the second power because there's two of them. Another thing, you list all different factors in each denominator. Okay, so every single different kind of factor you see in all the denominators, at least one of those must be in the denominator. And remember, if it repeats, you need to make sure you write it with the exponent that relates to how many of them you have. Now, after you grab one of every single different kind of factor you can see in the denominator, like we said in the last slide, if each denominator shares a common factor, use the factor with the highest exponent. So you probably already see here, like, see how there's an x plus 2 in each denominator? So we're going to be using the one with the higher exponent, which is x plus 2 squared. Okay, so to figure out how we make common denominators between two fractions with polynomials and monomials, go ahead and pause the video and watch examples 3 and 4. Here are the funsies. Yeah. Okay, now this is where it gets a little tricky, you guys. We will now be adding and subtracting fractions with unlike denominators. Okay, so they will not be common denominators. They won't be all nice and pretty like these were for us. So if I go back to these problems, these are nice and pretty for us because our denominators are already alike. But now we gotta step it up a notch. The harder the problem, the more exciting the problem. So that was too easy. We gotta step it up. And guys, the steps for this are the same, okay, but we have to take into account how to make a common denominator, which you're gonna be using the same skills to make a common denominator that I taught you in the previous two slides. Okay, so when we do this, the first thing is to factor all the denominators, which in this example problem, I can't factor the 2 and 3. Nothing else goes into 2 and 3 except itself or 1. So this is factored. The next step, we must make a common denominator. Okay, which the common denominator, remember we grab one of every single different thing we see, which I see 1, 2, and 1, 3. So my common denominator will be made up of a 2 and a 3. Bam! Which when I multiply them, they'll be 6. But when we have polynomials, we don't really multiply them together, so that's a little irrelevant, but it doesn't matter. Okay, now, what we will be doing. So I have my 1/2 and my 2/3. I'm going to force these fractions to have a common denominator, whether or not they want to. We're going to be quite mean to these fractions, unfortunately. Okay, so what you need to do, you need to look at the common denominator and ask yourself, what is missing in my denominator from the common denominator? What else does it need to get to my common denominator? So like my first denominator has a 2. My common denominator has a 2 and a 3. So the piece of this that's missing is my 3. So this fraction needs the 3, which means I need to multiply the 3 to the 2. But you can't just multiply something to the denominator. If whatever you multiply to the denominator, you must multiply to the numerator. So since I'm multiplying 3 to the denominator, I must also multiply it to the numerator. Okay, now this fraction, I must look to see what else does this denominator need from my common denominator. Currently I have a 3, which I have a 3 there. Okay, so currently it's missing the 2. And remember, in order to get my common denominator, I must multiply the 3 to the 2. But if I multiply it to the denominator, I must also multiply it to the numerator. And guys, all we're going to do is multiply these two sets of fractions together, which when we multiply with fractions, you go straight across and straight across. So 1 times 3 will give me 3, and 2 times 3 will give me 6. So this will be 3 over 6. And this one, 2 times 2 will be 4, and 3 times 2 will be 6. So this will be 4, 6. Okay, so we'll have 3, 6 plus 4, 6. And now that we have a common denominator, we go back to those same rules we used before. You keep the denominator the same and add the numerators to get 7 over 6. Alright, so I'm going to show you a more complicated problem. So let's look over here. So again, the first step when we're coming up with a common denominator and adding these fractions is to factor the denominators completely. Remember, we do not touch the numerator. Don't you dare even think about it or the demon cats are coming your way. Okay, so I need to factor these things. So what are some things that go into 4 and some things that go into 6? Well, 4 will break down into 2 and 2, and 6 will break down into 2 and 3, which 2 times 2 is another way to write that is 2 squared. So I brought my numerators down and then just rewrote my denominators as their factors. So my common denominator, I'm going to grab one of every single different number I see or different factor. So I see some 2s, so I need a 2, and I see a 3. Now my 2s are in each denominator, so remember, you must pick the one that has the higher exponent, which is 2 squared. So my common denominator will be 2 squared times 3, which is eventually going to be 12. 2 times 2 is 4, times 3 is 12. Alright, you guys, so I've split up my fractions. I must multiply to the denominator what it needs from my common denominator to get the whole thing. So this denominator has a 2 squared in it, so the only thing left for my common denominator is the 3. And remember, if I multiply it to the denominator, I must multiply it to the numerator. Now this second one, it has a 2 and a 3. So, my common denominator, though, has 2 2's because it's a 2 squared and 1 3. Well, I have 1 3, but I only have 1 2. So that means I need one more 2 to get my common denominator 2 squared. So I'm going to multiply 2 to the numerator and the denominator. Alright guys, and then it's just like before. To multiply two fractions, you go straight across. So 3 times 3 is 9, and -1 times 2 is -2. And it'll be all over my common denominator, which is 12. 2 squared is 4 times 3 is 12, and 2 times 3 is 6 times 2 is 12. And once I have a common denominator, you write it over one of them. So I'm going to write it over 12, and then combine my numerator. So it'll be 9 minus 2, which is 7. Ta-da! And guys, I know that was like really over-explained, but the reason why I did it is because this is the same process we're going to use when we add and subtract to polynomials that don't have a common denominator. So let's talk about that. So these are the same steps we had for when they had a common denominator. The only thing that's different was that steps 3 and 4. So after we factor the denominators, make sure the term with the highest exponent is positive, and determine where the expression is undefined by setting our common denominator not equal to 0. Okay, what we're going to do is come up with a common denominator. Okay, so we have to come up with a common denominator, and then we're going to be setting the factors not equal to 0. Okay, and after we do that, we will force the fractions to have a common denominator whether or not they want to. Okay, so just like over here, okay, we had to make them have a common denominator. So we multiplied our denominators by the piece of the common denominator that it still needed. Same idea with this. And the rest of the steps are the same. After that, you add the numerators together and keep the denominator. Okay, don't forget though, when you subtract, you got to distribute a -1 before adding. And then after that, you simplify and factor the numerator and divide out any like terms. So go ahead and pause the video and watch examples 5 and 6. Okay, you guys, complex fractions. Now, we're not going to get scared about these. They look a lot scarier than they are. So this right here, you guys, is a complex fraction. It's when we have fractions on fractions. We have a fraction over another fraction. Okay, but again, it looks a lot scarier than it is. So the steps involved, we're going to make only one fraction in the numerator and only one fraction in the denominator, which if you look at this one, the denominator is already one fraction. It's already together. This one, though, in the numerator, we got two separate pieces, so we must combine them into one. So we'll do that first. After that, it's simply just a division problem because we have our fraction in the numerator divided by the fraction in the denominator. And you guys are pros at dividing fractions. So after we write our big line with the division symbol, you'll just divide the fractions like we did in the previous section. So go ahead and pause the video and watch example 7. And that's example 8. Sorry, pause the video and watch example 7 and 8. And that's our funsie. Guess what, you guys? That's all, folks.